to show you how to configure enterprise banking network project. In this project, I'm going to combine this particular concept, Hub-and-Spoke IPsec VPN, SD-WAN, software-defined wide area network, VLANs, DHCP server, data center, IP addressing, and all other concepts. So, because of the complexity of the project, I have already configured the interfaces. I have configured the static routes. The static routes is just to help how the packets will flow on the network. For example, if at all I can just use the headquarter here as a point of reference, it will help when traffic comes from this particular computer to the internet. The static route will now direct the traffic from the source to the destination. So that's the function of the traffic static route. So the next thing that I did on this, I configured the firewall policy to allow this traffic to flow from the local area network here to the internet through the firewall. Also, I enabled DHCP clients by configuring the DHCP server so that all these clients can get IP address automatic because the complexity nature of this particular project. So all things that I did here, I'm going to show you. First, if I can just start with the headquarter firewall, you see I configured the interfaces and you can see this is port 1. This port is facing the internet. Remember, all ports on the firewall, port 1 is connected to the WAN, port 2 is connected to the LAN, then port 3 is the management port. So you can see the management port at this point, it has received the IP address. This is the IP address that I'm using to access the firewall in the browser. Then this is the ISP address. So this is the HQ. It is this firewall. So this is a company that has branches in 4 countries. That is Kenya. The headquarter is based in Kenya here. Then the branches are hosted, one in Nigeria, one in South Africa, and another one in Tanzania. So that I'm going to configure this particular lab in that when communication happens to come from the LAN connected to Tanzania, it has to go back to HQ before it comes back to intended destination. So this is what we call Hub-and-Spoke VPN. So I'm implementing this particular project using Hub-and-Spoke VPN to ensure that automatic secure IPsec tunnels are created, because in banking, the safety of data is more of significance in the day-to-day operations. So the bank has to ensure that the customer's data is so secure. The intruders or threat actors over the internet cannot access the data. So this is one of the scenarios that the bank do implement. They use what we call VPN, virtual private network, to create for users to access the internet through the tunnels, so that people who are outside that network cannot decipher what is being communicated. You see, banks deal with critical data. So this is the headquarter, and you see the headquarter is hosting the data center here. The data center is carrying critical services here. It contains the FTP server, it contains the email server, DNS server, the database server, the web server, all those servers that facilitate operations in a normal enterprise network. They are hosted on these two in the data center here. You see, our data center is containing the Windows Server DC. That is the domain controller. The function of domain controller is just to control other servers in that it acts as the primary. In this scenario, Windows Server is the domain controller. Then there is Ubuntu Server. For security purposes, this is the one that is hosting mails, files, and databases. So now, to ensure that every branch has day-to-day access to the files or resources hosted in the headquarter, I have included the SD1 failover here, so that when the failover will just help to ensure that this particular file is up throughout, so that when this link fails, still it can remain up through using the Nigerian branch. You see, in Nigeria, most of threat actors or frauds are fraud people. Like, generally, according to this particular bank, we've got more security threats emerging from Nigeria. That's why I have conditioned it in line with this SD1, so that it remains up in relevance to the data center here. These are the LAN. This LAN I have just simulated singly using this particular subnet, but in real sense, due to time and space, it contains multiple VLANs or multiple subnetworks that are anchored on these switches. So this is a complex project that I'm configuring step by step so that you can understand. So I'm going to show you what I did on these firewalls at this stage. So I'll start on the HQ. The first thing you see here, I have specified the DNS. So if you use, these are the default DNS for FortiGate, but now I'm not using this one. I'll choose mine. So once you do that, you apply. So that is one of the things that I did on this file. We go to the interfaces. You see how my interfaces are configured. This is for the LAN, then this is for the WAN, then this is for the management. You see the static route is already created here. The static route is already created. You see, this is the route. You see, this is the route that was created. On Nigeria, you see, this is how I specify the static route. It means any device on the internet. Then my gateway being dynamic, I just chose the Nigerian one, then dynamic, then I apply. You see, gateway interface conflict with the existing static route. So I had already created, there is no need. This is the rule, you see. So .10.87. So there is a problem here. Just take that, then access to our file. So once this is accessed, so that's what I did on that firewall. Let me show you the firewall policy. This is the firewall policy that is enabling traffic to run from the local area network to the internet. So my incoming port is this particular port 2, the one that is bringing traffic. Then outgoing is the one port, this port here, this port 1. Then everything, source all, I'm allowing all from that subnet. Then destination is everything, always, schedule is always. Then the main thing here is ensure that NAT is enabled, because internal IP are going to be translated into the one at the ISP. Then at this on logging option, logs are immediately started upon when the session starts, and we are logging for all sessions. So this is what I did on entire firewalls. Also on the interfaces, I enabled the DHCP. This one I enabled the DHCP, you see, the name of the interface, alias, then the role of the interface. This is the IP assigned to that. Then these are the administrative access or the services allowed on this. Then DHCP, it is this. I'm conditioning my DHCP server to start issuing IP address from .20 from that particular subnet. Then I save. So that is the far that I did, at least to save on time. I have done on every firewall, you see. So just to confirm, we can execute and ping google.com. You see, we are able to ping we are able to reach the internet. That is Google DNS, you see. So same applies to every firewall. We can do that, execute ping 88, execute ping, then 88. You see, we are able to ping. This is just a confirmation that my execute .11, you see, I'm able to reach. Then from Tanzania, let's also confirm, execute ping, then google.com. You see, we are able to access Google. So this is through the power of this particular security firewall policy that was created. That rule helps us to reach the internet. So at this stage now, I'm going to configure the SD1 between the headquarter office and the Nigeria, so that when Nigeria is down, this HQ will be up and will still serve the Nigerian land because of the complexity of the nature of the operations in that particular branch. So the first thing, I'll start with the SD1. I'm going to create a zone, then bundle the members on that zone. So create a zone. So this bank is Equity Bank. So that is the name of my zone, Equity Bank SD1. SD1 zone. So at this point, I'm just creating a zone. Now on this zone, I'm going to create members. So the members here, the members that are going to be within this zone is Liquid Telecom and Safaricom. This is .138, then .72. You should master that. So create a member. So you pick I'm not editing, so create SD1 member. So once you pick your zone, let's check something here. There is something that is not right. The role is the 1. So once we do that, let's now try. So I think there is a problem with this. Let's edit our zone. Because at this point we have to choose the member. So we can just do this, delete this, then create a member. Let's come on Nigeria here. SD1 zone. Then the next, we try to create a member. So according to this particular version, according to this version, let me reboot my firewalls, execute reboot. There is something that is not moving right here. Execute reboot. So I'm rebooting the HQ and the Nigeria. So at the moment, I need to enable the SD1 failover between this particular firewall and the firewall in Nigeria, so that when this one is down, this one is up. When this one is down, this one is up. At one point, this one will also serve as the one in Kenya. So let me check the status of the firewalls. So you see the system is restarting. So once Once this one is starting, I'm going to configure the auto discovery VPN on these firewalls so that this one will be, so it has finished restarting. So let's access it. We'll just reload. Then same applies to this. Admin, then admin. Same applies to Nigeria. We log in. So you see, it's not, we are unable to reach this particular IP. So let's try whether our management IP interface has changed or not. It has not changed, it is the same. Diagonalize IP address list, that is 88, it is the same. So you see it's up, admin, then admin, admin, then admin. So I'm going to configure the SD1, the hub-and-spoke VPN. This is going to be my hub, HQ VPN, then the hub-and-spoke, then the role is the hub, then next. Incoming port is the one port. Then at this point, I'm going to use this as pre-shared key. Then next, it will automatically, using BGP Border Gateway Protocol, it will assign the IP address. Then I will choose the local interface. You see the subnets, the spokes. It has only detected automatically spoke 1, but I have how many spokes? Nigerian spoke, South African spoke, then Tanzanian spoke. It means by a spoke, I mean the branches that I have. All these branches must be synced on the HQ. So what I will do here, I'm going to choose individual, then add. I have 3. This is spoke 1, spoke 2, spoke 3. So Nigeria, South Africa, and then Tanzania. You create, you see the configuration keys. These are the authentication keys that are going to be used to authenticate. So like spoke 1, this is spoke 1 is the you see this is spoke 1. So Nigeria, I'm going to authenticate that in Nigeria. IPsec tunnel, we just do the same as we did on that. Nigeria. Nigeria, so we pick the hub, then the role is the spoke. Then we paste the key. Next, you see it has detected 138. 138 is the IP address for the interface facing the ISP, Fortinet. So at this point, we just pick the LAN. Then we've created that. If we want to see the tunnel still is down. So the same, we go to South Africa, you pick the authentication key, configuration key number 2 for spoke 2. Then you come on the IPsec tunnel here, South Africa _VPN. So the name is too long, so I'll just s.africa, then it will be spoke. You paste the configuration key here, you apply. The moment you apply, you are invoking the border gateway protocol to come into place. Then you see it has detected the hub IP. You authenticate using the pre-shared key. Then the next thing is you just bind with the local subnet. Then you are good to go. Same applies to branch 3. You just paste that. Just copy the configuration key. The steps is that you pick the configuration key, you give the name of the VPN. Once you give the name of the VPN here, TZ VPN, then you specify the type of VPN template, then you paste that, you apply. You give the name of the VPN, you specify the type of the VPN template, you choose the role of that, whether hub or spoke. Spoke is for a branch, hub is for the controller. Then you paste the configuration key generated here in the main firewall. Then you apply, then you enter, you authenticate yourself using pre-shared key. So this is the key that is always used for you to connect to the VPN. The moment you do that, it will detect the IP address for that branch automatically. From here, we just add the LAN, then we create. At this point, I have managed to configure the Hub-and-Spoke VPN. So when we go to IPsec tunnels at this point, you'll notice that 3 dial-ups. It means 1, 2, 3. Nigeria, South Africa, Tanzania. So when you just want to check more about this, you see the tunnels have been created automatically and traffic is passing. So the detection of this particular traffic is the one that we tried to verify initially. You see, this traffic is what you are seeing here. So, but you see at this point is down, so you just refresh, just reload, then same applies here, you just reload. Once it finishes reloading, you'll just come on the, you see, the dial-up is up. You see traffic is passing through. This is Nigeria VPN. Just to see the tunnel. So you just you can check the tunnels at this point. So you see, traffic is passing through. You see, traffic is passing through. The bluish, it means traffic is passing. So this is tunnel 1, tunnel 2, tunnel 3. All tunnels are here. So this is how we configure Hub-and-Spoke. So I want to test something. So this version of the firewall is this one. So for port 1, let me give it IP address automatic so that I test something. So you see, the moment I have done that, you see the VPN tunnel has been created. Same applies here. There is a plus sign on the one port. You see, the tunnel has been created. And you see traffic is passing. This is the DHCP ranges. So once we are done at this particular stage, let's now enable the clients and test communication. First of all, you see, I'll start with the headquarter office. So the headquarter is being served with the data center here. You see, this particular machine The Windows Server, I have configured it as a separate virtual machine and linked it to SD-WAN so that on the FortiGate, you can see that this is the domain controller. Let me log in. So you see, so this is the server hosting the services. So this one is the Windows Server. It is the one serving as the Active Directory. So you see, it received this IP, then IP config, we release the IP. You see it is saying updates available, so we renew. So it has received that one. Let's ping. It is not going through, so ping 192.168.122.1. It's failing, so we will ping this one. So this is the server. Let's go to the next client. I'll enable this IP DHCP. DORA successful. It means that we've succeeded. So ping 192.168.122.1. So there is something that is not right. Let me just check on the interfaces. Port 1. You see it is connected on this IP. This is the date. Everything is okay on that. So because of this, I am now to test something. Port 1 is hidden. So let me try to create SD1 between the branches. It's a firmware issue. You see, so these are the limitations that you'll come across if it's not a real device. So the firmware of this particular, it's not supporting the SD1. So I can just do the high availability to replace the SD1 here. So on this, I can just edit this. So high availability in active passive. So in this now, I'll configure the high availability between the headquarter and the Nigeria, so that I'm going to, so now SD1 has failed to work. I'm going to use high availability as an alternative to provide redundancy in that particular, in the two FortiGate firewall. So I will start with the headquarter. So the headquarter is going to be the primary. So between these two firewalls, I'm going to use port 4 and 5 as the heartbeat interface. So I'm going to pick port 4, then port 5. So once I pick that, I'm going on the system, then high availability. It is going to be active passive. Priority is going to be 250. So the name of cluster is banking. Then the password, I'm going to change Fortinet. No, it will collide with the previous password. So session pickup, you enable session pickup. The monitoring interface is the one interface under LAN. So the WAN and the LAN are the monitoring interface, are the ones that will invoke the heartbeat interface to switch the either primary or, so this is port 4, then port 5. The management interface here, I'm going to retain the same. The management interface is port 3. Then the gateway is 192.168.10.87. So once you do that, the firewall will reboot. The firewall will reboot. So the reboot process will now try to find the primary, the active, the passive firewall, so that it can synchronize. So this is how we configure. It's just a simple thing. Monitoring interface is the one and the LAN. Then heartbeat interface is it is port 4, 5. Then we reserve the management. The management is port 3. Then this is having 192.168.10.88. So reserving the management, it means that the management IP will retain. It will not keep on changing. You see, this one is booting. Then also this one, it's booting. So you give it time. Execute, reboot. You can just reboot them on the CLI. You see, secondary external files are not in synchronous. So it is trying to find the active firewall in the cluster. You see this comment. Execute, reboot. So it is restarting. So let me explain something here. High availability is one of the redundancy feature in modern enterprise network that is used to eliminate a single point of failure in terms of operation, network, and security operation. So that when this firewall, Nigerian firewall, is down, then the Kenyan firewall will be up to serve the Nigerian LAN. So this is one of the feature, and it is configured in different modes. We've got active and passive, whereby one firewall is the primary, then the other firewall is the secondary. So in this scenario, the backup or the passive firewall waits until the primary firewall fails. That is when, through the power of heartbeat interface and the priority and the time it has been up, then the uptime, then it switches to be the primary. So the factors that affect the firewall either to be primary or second, first of all, is priority. The higher the priority, the higher the chances the firewall to become the primary or the active. Also, the longer the time the firewall has been up in the operation, the uptime, the higher the time, the higher the chances it gets elected as the primary. We've got a feature called preemption. Preemption is not enabled because when you enable preemption, it means when this firewall goes down, then the passive firewall picks up as the primary. When this one comes up, when preemption is enabled, it will automatically snatch the active capability from the passive firewall to its initial state. So that one sometimes bring about downtime and some drops within the network traffic. So we disable preemption so that once the firewall has taken the role, it uses the role until the time it will fail, so that the other can assume that particular role. So let's check whether our firewalls have synchronized. Let me log in. First of all, we check the management IP. You see now it has retained the IP, but you realize it has created a lot of some addresses here. So you see HAV, high availability. You see high availability, these two interfaces, you see. Then you see something here, port underscore HA. HA means high availability. You see this particular tunnel here, this is the IP for the VPN, HQ VPN. Let me just zoom so that you can see this particular statistics for this project, because it's one of the complex projects that you cannot afford to miss. So now see, we start here. This is for port 1. This is for port 2. Then this is for port 3 management. So the normal ports that we used to have before, those are the ports. But we come here, you see this one, HQ VPN. This is the tunnel interface. The tunnel interface is being served with this particular IP address. You see, the source is this, then destination is this. You see, HQ VPN. Then there is this 169.254.0. This one is port high availability. So this is one of the port that high availability feature is using to synchronize between the firewalls. You see, so that the destination and the source is using the same IP address. Then there is this one, FGM. This is the management port that is bound on this management IP, port 3. Then these two IPs you can see, there is 65, then 65, then 66, then 66. So you see, high availability, destination link, 0 and 1. So I believe at this point my firewalls have synchronized. The Nigerian firewall, you can see the Nigerian firewall and the Kenyan firewall. Let me just make it larger so that you can see the statistics. Secondary external files are not in sync. Then second starts to sync. You see, at this point there was no synchronization, but at this point secondary starts to sync with the primary. So there is synchronization. It has locked out all admin users. So we have to log in, then show system high availability summary. You see, the group name is banking. This is the cluster name. The mode in which the firewalls are operating is A to P, that is active to passive. Then this is the password that was set to authenticate the synchronization. Then the HPDEF, it means heartbeat interfaces. It is port 4 and port 5. Then session pickup, it is enabled so that when that one is down, the other one is up. So without enabling this one, the firewall will not be in position to determine whether the primary has failed or not. So the management status is also enabled to determine which one is the backup, which one is the active. Then you see at this point, port 3 is the management. You see, the high availability management that I reserved, it is port 3. It is operating to on this particular IP address. This particular configuration here, it just invokes the firewall to know that this is the management IP, even though you synchronize whatever to that is on the other end to this end. Do not synchronize or dilute the management IP. Let it remain the way it is. That's why we are still accessing the firewall using the same IP address. Then you see the override. This is the preemption part. It is disabled. When this is enabled, this is the active. This is the passive firewall. When the passive firewall assumes the primary role, then it happens that the primary role is down. The primary firewall is down. When it comes up, it will immediately snatch the primary functionality or the role from the passive firewall. So that one will bring some effects, disruptions on the network. To avoid that, we always disable the preemption, which is called override here. Then the monitoring interface is the one interface, the interface facing the ISP, Internet Service Provider, and the interface facing the LAN. So the two interfaces are the ones that give the signal to the firewall whether the other is down or not, because the traffic is reachable and unreachable. So when now we go back to our firewalls, you will notice that the firewalls have synchronized at this stage, creating expected arguments to be so you see it has synchronized. The HQ firewall is operating at 250. That is the primary, the active one. When this one is down, it will be helped by the firewall in Nigeria, because you see these are the serial numbers. This is the role. It has been up 9 milliseconds, 25, 9 microseconds. So this has the higher number of the high uptime. So the uptime, the system uptime, the priority, it will give it a head start for it to serve in the primary. So this one, execute, reboot. You can just reboot it again, no problem. So as that's how I have configured these two firewalls. That's how to configure the high availability on FortiGate Firewall. So you see I have configured this between the headquarter here and the branch. So the next thing, I'm going to configure the captive portal. To configure the captive portal is simple, but it needs so I'm going to configure the captive portal in that when this one accesses the internet, you have to log in. So I'll edit this one. I'll ensure that this computer gets IP address automatic by enabling it to be DHCP client. Once I do that, I'll stop and start again. You confirm what you did. So at this point, I expect this computer to get IP address automatically. So I'll access the console. it's saying no connection. So let me just stop, then reload. I can just delete, then bring another device here. So I'll connect this one and on this. Once connected, I will start. You start this computer, then you edit. This is not like the normal VPC. So once you do that, you access the console. You check whether it has received the IP address automatically. You see it is still. So you just close this one, then stop. Then start this one. So the moment we configure captive portal, at this point we will see a pop-up saying that you have to log in for you to access the internet. So at this stage, you see it has received this IP address. It has received this IP address, so there is an alternation here. But let me just configure the captive portal on this HQ firewall. So you see, synchronization is happening. To configure the captive portal, you will just come on the user identification, user definition. You create a user. Admin1, then password is admin1, admin1. So once you create a user that way, you create a group captive portal. Let me give it captive users. Then you add the members. The members is admin1. Click OK. Once that is done, you enable the captive portal on the interface. That is the LAN interface that is facing from the FortiGate firewall to the LAN. So on that particular interface, there is this part, security mode. You enable, then you choose captive portal, then restriction, restricted to a group, then you choose that group. This is captive users. Then exemption, you leave it the way it is, then redirect after captive port. I'm not going to choose any URL. So the moment I save this one, you'll notice that the moment I finish that, then reload this page, let me specify the role. Security, and then specify the role. I'll just give it facebook.com. So the issue here is it is being caused by this issue. So I can just captive portal, I'm going to configure it also on the Tanzanian. FortiGate, so that you can see. So you start, you edit the config, you enable it, you give it DHCP, so once that is enabled, just confirm it has received the right IP address. You see it has received this IP right from that subnet. Now let me enable, this is Tanzanian FortiGate, let me enable FortiGate Firewall on this user identification, user definition. I'm going to create the user. So at this point, you can just log out. Once I'm going to show you how to, once this, you see, first of all, let's try to ping the internet. You see, we are able to ping the internet. That's good. So you'll see a pop-up here that you must log in to access the internet. Failed to load data. Tanzanian firewall. Execute. Reboot. So let's give it time as it finishes rebooting. So on this, let's test. Let me show you how to test the VPN. So on the South African machine, I'm going to ping 192.168.122.138. IP DHCP. Then we save. So once we do this, now let me show you the generation of the logs. You come on the logs, forward traffic, so at this you can see 9-second circle. Traffic is coming from this computer. The destination is this one. This is the rule that is helping that, and the computer itself is this one. This one, you see, traffic is going. So that's how let's check the Tanzanian firewall, what's not happening. So admin, diagonalize IP address list. You see it is still on 90. So we give it time to synchronize and log in. If you want to test if that IP is reachable, you just access the ping 192.168.10.90. You see, it's reachable, so there is no need to worry. Execute ping. You see, I'm able to reach the internet. So let me go a bit faster to configure the captive portal on this Tanzanian FortiGate. So this is traffic, it's going. High availability events, you can get them here. You see? So captive portal, I'll go to the user definition. So the Nigerian firewall, I'll just stop it. Then reload. Then start. That is, it's like hard restarting, so it will just start that session. So captive portal is one of the modern security implementation that is used to ensure that resources are only provided to the people that need it. So users have to authenticate using the password and username for them to access the resources. So at this, let's create a user, a local user, director, then admin. Once we create that, we have created that user, then we create the group, captive portal users, then we add the members, that is director, then okay. Once we do this, we come on the LAN interface. This is Tanzanian LAN. We enable the security mode. We choose that captive portal will restrict to a particular group. Then we choose our group. Then on that, we leave everything the way it is. We specify the URL. Maybe facebook.com. So when you want to go to facebook.com, you have to enter the password and the username. So once that rule is applied, we can reload. Now it's applied. So we will come to this, then reload. So facebook.com. You see, you must log in to this network before you can access the internet. So you open the login page. So you will be given this page, the firewall page, so that you can put your credentials, director, and then admin. This is the so when you are authenticated, you see, you are now, the firewall has proved now you are going to the Facebook. It is not so that direct. You have to put the password and prove yourself before you enter on Facebook. So I just don't want to log in, or I can 07. So that's how you authenticate captive portal. So thank you so much for following step by step on this lab. So keep subscribing, keep liking and commenting. In case maybe you have an issue on this particular project, please let me know how we can help each other via the comments. Thank you so much.